Welcome back to Greenplum 2020, Greenplum Summit 2020, the reimagined digital customer conference. My name is Jacques Eistock, and my next guest is Michael Short. Michael is from one of our premier data science partners, A42 Labs, and he's going to tell us a little bit about how to use Nuix and PXF, which we just learned about from Ashka and Francisco, Nuix and PXFs to load unstructured data into Greenplum, and then what you can do with it. So Michael, can you tell us about your experiences?
Yeah, definitely. So hi, I'm Michael Short, data scientist at A42 Labs, partner with VMware. And just thanks for joining this presentation. It's on loading unstructured data into Greenplum using Nuix and PXF. And so first, a little background on us at A42 Labs. So A42 Labs is an AI and machine learning software services company. We help innovative companies build, deploy, and manage enterprise-grade solutions. Sorry. One of the services we offer is data science consulting. Our data science team works with customers and partners across a wide range of industries, financial services, banking, finance to retail, logistics, and everything in between. And so me personally, my background is in mathematics and machine learning. And I've been with A42 Labs for a little over a year. And in that time, spent a lot of time working with Greenplum. At A42 Labs, we use Greenplum database for everything from reporting and business intelligence to some more sophisticated workloads like the one I'll discuss with distributed machine learning across large data sets. So for this presentation, I'll review a use case where we use Greenplum and PXF to help a customer with electronic data or document compliance. Specifically, we built a machine learning solution that helps us identify emails indicating potentially non-compliant behaviors, one example being insider trading, and help the company's internal document review team audit these emails more efficiently. So currently we're working on a public-facing demo for our website of this solution, and that leverages the Nuix engine for information extraction, PXF for loading the data, and Greenplum for querying it. In this presentation, I'll kind of review what Nuix is, the architecture we used for our whole solution, and some technical insights I found regarding PXF, and then finish with a quick summary of the results. So I can't really share too many details about this customer's use case, but at a high level, I can say we're able to use PXF and Greenplum to build a solution that was identified emails for audit accurately enough to provide, I think it was an estimated $1 million in yearly savings. And in order to accomplish this, we leverage both PXF and Nuix in a way that's scalable and generalizes easily to future use cases using unstructured data. So specifically for this use case, we're working with a company that's required to keep emails and attachments in storage for future review. And then by scanning these documents proactively, we're able to identify restricted activity and help reduce the risk that it exposes their organization to. Our solution in particular was able to reduce the number of false positives that the audit team had to encounter. And they review about 2,500 files a day. And so, like I said, it led to an estimated cost savings of about $1 million annually. This problem isn't unique to the finance industry. It's not an uncommon problem. A lot of companies are required to keep document retention, required to do document retention for electronic storage. So since I've been with A42 Labs, I've worked on several use cases like this where customers want to either automate or augment a manual process like reviewing these documents with machine learning. And the key to realizing the value of this type of work is to make sure that the model actually makes it into production, which a lot of machine learning models unfortunately do not. So I don't have time in this talk to kind of go into the details of how we productionalize this model, but hopefully in a future webinar, I'll be able to go through those details a little more deeply. So before we push our machine learning models to production, we have to train them. And the first phase of this process is our data preparation. So for our document compliance use case, data preparation consisted of parsing the emails themselves and attachment data for the emails attachments and structuring the information to a table so that we could perform downstream activities like loading it into a machine learning model and doing some reporting on it. So there are a few challenges that we encountered with this. First, there's hundreds of different file types that get attached to emails in a company, right? We're looking at a mixture of Excel spreadsheets, PowerPoint, Word documents, PDFs, text files, TIFF images, and it goes on and on. The second challenge that we ran into is just the sheer size of the data. So the customer we worked with, I think they had over 2 years of data on file, and that was hundreds of millions of emails. And thankfully, thanks to being able to use PXF to load it in quickly into Greenplum and then build a machine learning model on top of that, we were able to build a performant enough model that we could process this data in a reasonable amount of time. And you can imagine going through hundreds of millions of emails manually. So this was very cost effective for them. So to process this massive amount of email and attachment data, we use the Nuix platform, which is able to extract both content and metadata from emails and attachments that are stored on client servers. This software has a built-in data analysis GUI that's powerful on its own, but for our sophisticated NLP use case, we leveraged its ability to extract the data that it holds in its internal database into a JSON format. And for the publicly facing demo that we're building right now, we're using emails and attachments that indicated insider trading from the Enron trial. And so in that case, we're dealing with about 1 million JSON files after deduplication. So that provides a pretty good volume of data for demonstration purposes. So using Nuix has allowed us to benefit from its high performance and extract both metadata and content from files, which this capability isn't really available in most open source solutions. It also allowed us to tag audio and image files and process complex file directories. We didn't have to use these last two in our use case, but we're looking forward to applying them to future machine learning use cases. Two features that really set Nuix apart for this type of work is that it's able to parse thousands of different file types and extract data from a variety of file system structures. So for example, with Nuix, we extract data from PDFs stored in a zip file, and even if that zip file is combined with other zip files in a parent zip. Another example would be if we wanted to extract all of the data from a disk volume, we just kind of point it at the hard drive or the root directory, and the engine kind of runs on its own and does its thing, tagging and extracting the content for each of these data types. So there's a lot of detail on how we pulled this together, but this diagram is just kind of a high-level overview of the overall architecture we used. To simplify the storage and data lifecycle for our client, we stored JSON files in an S3 bucket and then leveraged PXF to load the data into Greenplum instead of having to write a separate ETL process and then manage the data separately in Greenplum. And then once it's in Greenplum, we're able to use the data to train our machine learning model and perform some reporting on the results. In this architecture, we chose to write the data to S3 instead of Greenplum directly because, well, Nuix can write it to either, but storing it in S3 allows us to utilize Greenplum without keeping the cluster running 24/7 in our cloud environment. And so if we use S3 as our data persistence layer, we can spin up Greenplum on demand when we really need to, load data or do reporting. And we found for data science workloads, for us, this significantly reduces the cost of running Greenplum in the cloud. So why do we use Greenplum? Well, Nuix has its own data storage. It uses, I think, Elasticsearch under the hood. But in the future, we kind of looked at the capabilities of connecting directly to Elasticsearch for other machine learning work. But for Greenplum, kind of it's our first choice because of our past success with using Greenplum and, our ability to kind of do a lot of distributed computing on it and load data in parallel, kind of what's been mentioned before, specifically for NLP use cases. In this use case, we used Google's BERT model on a GPU cluster. And so having parallel access or parallelized access to data was really important for this. As I mentioned a little earlier, in a future talk, we'll plan to kind of go into more detail on how we use Greenplum for the modeling part of this. But thanks to being able to connect to S3 using PXF, we were able to implement a BERT model that could suck the data out of Greenplum and then write its results, kind of the vector embeddings for the text of the emails and attachments directly back into the database for reporting. So during this project, I learned a lot about Nuix, Greenplum, and PXF. And so here I'm going to kind of go through some technical insights that we had specifically regarding PXF. And so first I'll go through some common ways that JSON data is stored in text files and how we loaded each of these formats into Greenplum with PXF. Then I'll discuss why you would sometimes choose to load the data as a text data type instead of JSON, like having a JSON data type for the column that you're loading the data in. And finally, I'll go through some kind of pros and cons of using external tables with PXF. So we go through about 5 different JSON data formats. So here's the first one, and it's where you're dealing with a single JSON object, one object per file, and that has no line breaks. So you can kind of see the example down there. And you can see, like what was shown before, after the location in the query, what the PXF URL looks like, and that we're using the S3 JSON profile. We hit our access and secret keys for obvious reasons, but we're using the custom format and the PXF writable import format like you kind of saw before. So this worked kind of out of the box for us, which was great. So another common format that you run into is where you have a single object, but there's line breaks, for instance, between the fields here. And so we discovered that you actually have to add the identifier URL parameter when dealing with this specific file type to make it load correctly. So another common file type that you run into is where you have multiple JSON objects in a single file with no line breaks. So you can see the example there. And for this, we found that you also need to use the identifier parameter as well in order to make it load correctly. And then finally, not finally, we have one more after this, but for this, we found that if there's line breaks within the different fields, again, you have to use the identifier parameter to help it load. And then finally, for the JSON file types, we found that if the JSON, they don't have to be separated by a comma like you would see in a JSON array. If you have kind of the JSON objects in a single file separated by multiple line breaks, again, using the identifier GUID, it just kind of intelligently figures out, okay, I need to load these 4 JSON files as individual records. Okay, and so here's an example of using the text. So you see the data is a CSV file. And here we use the S3 text profile and the format CSV instead of the custom PXF writable format. But again, you're able to load it directly into Greenplum using PXF with this configuration. And you can see this works for CSV files or text files that you have multiple records in, not just one. You don't need the identifier URL parameter for this one. And then finally, you can use the text profile. In this case, you use S3 text multi. If you have a JSON file that you want to load in just from a raw text file. You still use the format CSV, but again, it kind of intelligently figures out how it works. Okay, so let me catch up one second. Okay, so here I'll talk about kind of using JSON data type versus the text data type. So when loading in any external data, PXF allows you to set a maximum number of errors that it'll tolerate, specifically when reading into a JSON column. This limits the number of files that it'll skip if you're reading in a file that's not a valid JSON format. However, as data scientists, we sometimes deal with a huge amount of data in unstructured formats that we don't really know if it's valid JSON data or not beforehand, and we don't really necessarily know what each field contains. So in this case, we found it easier to load the data in as text and then validate that it was properly formatted within Greenplum itself. And so you can use the built-in JSON operators in Greenplum, or if you need kind of more extensive functionality, you can load in PL Python and use the JSON package from Python to kind of parse this and validate that it's in the proper JSON format. So for our example, we found that we could fix most examples with just a basic case statement, but if you have a lot of complex, or you have a very complex data structure, you can, again, leverage PL Python to kind of parse that text. And so here, this is just kind of a printout of the example that it printed out to the terminal of a case where we did run into hitting our error limit because we had a bunch of invalid JSONs. You see there's over like over 1 million, and we set our error limit at about 1 million. So this is just kind of an example of what it looks like, and then a link to where in the documentation you can find how to handle that specific use case or issue. So finally, I'll talk through some advantages and disadvantages of using external tables defined with PXF. The advantages are that it allows us to connect directly to very commonly used data sources like S3 and Hadoop. And it's customizable in the sense that if we want to connect to a data source without a pre-built connector, because it's open source technology, we can write our own custom connector if we need to connect to, say, a legacy data source. It allows us to separate our storage and compute, which for us simplified the data management and reduced a lot of the Greenplum running costs associated with keeping a cluster up full time. And finally, it allowed us to do some sandboxing and some kind of testing with Greenplum without actually having to spin up a new cluster and then copy all the data over again. So for us, kind of the main downsides of PXF is it was a little slightly slower to read in the data from S3 the first time comparing to reading data directly off a disk in Greenplum. But this is something we kind of expected at the outset. And as you saw in the previous presentation, the R&D team is really working on improving that and especially speeding up the connection with S3. Also, as with most software, there were a couple advanced features and configurations. For instance, in our case, we looked at like tuning memory allocations, and they weren't super easy to find in the documentation, but after talking with some of the data engineering partners at VMware, we were able to find it and easily figure out what we needed to do from there. It's just kind of a summary here. So at A42 Labs, we were able to leverage PXF and Greenplum as part of a larger machine learning solution, and it helped us identify potentially risky emails for our customer. We leveraged Nuix to process the email and attachment data, and we're able to quickly get up and running, or quickly get up and run using Greenplum thanks to PXF, which allowed us the flexibility to store data in S3 rather than write a separate ETL process and deal with another set of data that we had to manage. And all of this allowed us to quickly utilize attachment data in our NLP model and significantly increase its accuracy over a model we built with just email information alone. So I just want to thank you for your time. If you have questions, please direct them to me in the chat and I can answer them, or someone else from the Greenplum or the VMware team can answer them. If you're interested in using A42 Labs for data science services, please feel free to reach out either at our website or at the email listed on the screen. And thank you very much. I appreciate your time.
Thank you, Michael. I really appreciate you showing us, real world examples and highlighting both the good of what we bring to the table, as well as places that we can continue to make your lives easier. I know we have a long, deep partnership, and when we're looking for top-notch data science help to augment our team, A42 has always been one of our go-to to engage with. So thanks again. Really appreciate it.